Hello. So in this very brief lecture, I'm going to show you how to resolve a force along two directions. So I've drawn a very standard picture here in mechanics. I have a block on an inclined plane. So gravity is pointing down, and the the inclined plane, is at an angle alpha to the horizontal. So the weight of the block is pointing down, and I've shown the weight vector here, W, pointing down. So the block obviously is an extended body, but all of the forces acting on the block act through the center of mass. So I can treat the block as though it were a point particle, and that's what I've done here, indicating the center of mass as this big blue spot. And so the weight vector emanates from the center of mass. So always with these problems, we're interested in the motion of the block, either up or down the inclined plane. And the most sensible thing to do in a situation like this, when you're setting up the coordinate system, is to have your x-axis running along the inclined plane and your y-axis obviously at right angles to the x-axis, so normal to the plane. And the challenge then is to resolve the vector w into its components along the x and y directions. And that's what I'm going to do here. So first of all, some trigonometry. So let me highlight a particular triangle. This is a right angle triangle. So this angle in here will be 90 degrees minus alpha. Because all of these angles in the triangle, all three angles have to sum to pi, or 180 degrees. So this one here is pi over 2 minus alpha. Okay. So we're going to try and highlight a different triangle next, or rather a different angle. So if we look at this angle here, it's necessarily pi over 2. So this would be the complement. And the point is, this is a right angle. So this is pi over 2 minus alpha. The whole thing has to sum to pi over 2. So that means the remaining angle in here has to be alpha. So let's summarize where we are now. Just removing all of these intermediate steps. We've now shown that this angle in here is alpha. And now it's plain sailing, in a sense, because what I can do, I can focus on those dotted lines that I had before. And I had my weight vector, which is down. Just move the next figure down. So I had my weight vector down. This angle in here is alpha. So if I, and of course the magnitude of the vector is W. So if I want to look at the components of W, this will be W sine alpha, because it's the opposite over the hypotenuse. And then this here will be W cos alpha, because it's the adjacent side. Cos alpha will be the adjacent over the hypotenuse. So with this piece of trigonometry, we can go back to our figure and we can draw in the components of W along the Y and X directions. So again, rubbing out the intermediate steps. So I will have W cos alpha and W sine alpha. And the final step then is to draw these components on the X and Y axes. So let me do that now. So I have W cos alpha, and I have W sine alpha. So these are the components of the vector. And once this is done, it's customary to put this squiggle through your vector to show that it's been resolved. And so when we're doing a force balance, we don't want to do any double counting. We don't want to count the weight vector here and then its components here again. That will be double counting. So the squiggle is just to say this vector is resolved and it's accounted for in its components along the X and Y directions. So maybe something just very slightly different. It's to look at this whole setup again. This is now maybe a shorthand. So this is the angle alpha with the horizontal, and we have the trigonometric argument y. This is alpha, and we want to resolve the components. So this is always the shortcut. Now that you've painstakingly gone through the trigonometry, I want to take the vector W and I want to project it or somehow drop it at right angles down onto the X and Y directions. So if I want to take the vector W and project it onto the Y-axis, cosine is always what you do when you're making a projection. So the projection of W onto the Y-axis is W cos alpha. So I get that immediately. And then to get the other component, well, it can't be cos. That's done. So it has to be sine. And yeah, that's the best way to think about it. So I project W onto this adjacent axis is W cos alpha, and the complementary projection is W sine alpha. That's the quick way to do it. So once you've satisfied yourself that the trigonometry and the algebra are correct in the first sketch, thereafter, just use this trick with the projection. Okay, thank you.